The overall goal of this method is to robustly and consistently generate engineered blood vessels of any size.
This technique allows the reliable and effective engineering of blood vessels. The main advantage of this technique is that vessels of any size can be easily and reliably fabricated.
We first had the idea for this method when we were discussing how to engineer a tube of tissue and likened our method to constructing roadway tunnels, one segment at a time.
To prepare the 3D printed inserts, first add a thin layer of 2, 4, or 6 milliliters of uncured silicone to the bottoms of a 35, 60, or 100 millimeter Petri dish, respectively. To create posts for the 35 millimeter plates, pour PDMS into a different 100 millimeter plate to a 7 millimeter height, and heat the PDMS on a hot plate at 60 degrees Celsius for 2 to 3 hours. When the PDMS has cured, use a 5 millimeter biopsy punch to create cylindrical posts, using a small amount of uncured PDMS to secure the cylinders to the center of each 35 millimeter plate. Place a 3D printed outer shell about 66.7 millimeters in diameter equidistant from the post in the 100 millimeter plates. Before the PDMS at the bottom of the 60 and 100 millimeter plates is cured, place 10 and 20 millimeter diameter 3D printed posts centrally into each 60 and 100 millimeter plates, respectively. Allow the dishes to cure in the open air on the 60 degrees Celsius hot plate for 2 to 3 hours, followed by 18 hours of polymer degassing. At the end of the degassing, sterilize the insides of all of the plates with 70% ethanol, and cover each plate for 30 minutes.